Now, this video is about kinetic particle theory. But first, let's start with the nature of matter. Okay, so what is matter? Matter is anything that has mass and takes up space. So we can say that all substances are matter, and this includes air, water, animals, plants, and mostly everything. So there are four natural states of matter: solids, liquids, gases, and plasma. For now, we only need to study three of these forms, which are solids, liquids, and gases. Now then, let's look at the particulate models of matter. Firstly, solids. Particles in solids are packed close together in orderly arrangement, and they have very little empty spaces between them, so they cannot move freely, but can only vibrate about their fixed positions. Particles in liquids are packed closely, but unlike solids, they are not orderly arranged. So they have little empty spaces between them, but more than that in solids. They're not held fixed and can slide over each other to freely move throughout the whole liquid body. Now, in gases, particles are far apart and in random arrangement. So they're free to move in random directions anywhere inside the container. These characteristics of the different types of matter lead to their respective properties, which are: solids have a fixed volume, a fixed shape, and is incompressible and it doesn't flow. Liquids have fixed volume, no fixed shape. It takes the shape of its container, and it is incompressible and it flows easily. Gases have no fixed volume, no fixed shape. It is very compressible due to the spaces between its particle, and it flows in all directions. Gas pressure. All gases exert pressure. When gases are heated, they take up energy and move faster, hitting the walls of its container frequently and with more force. Hence, heating increases gas pressure. When gas is squeezed into smaller spaces, gas can be compressed due to the space between their particles. So when the particles are closer together, they collide more often with the wall and hence an increase in pressure. Solids and liquids cannot be compressed due to their particles being very close to each other. Okay, now the kinetic particle theory. It states that all matter consists of many very small particles that cannot be seen directly, but they're constantly in motion and in a continual state of motion. And the degree to which they move is determined by the amount of energy they have and their relation to the other particles. There are spaces between particles, and the amount of spaces varies between each state of a particular substance, and also accordingly to temperature. The kinetic theory model can be used to explain the properties of solids, liquids, and gases by considering the molecules they're made up from and their motion. For gases, the kinetic theory model explains the gas pressure is caused by the collisions between the particles and their container. Okay. So next is the changes of state. Why do substances change state? Particles either gain or lose energy, which causes a change in how they move, their arrangement, and the bonds are made or broken depending on that energy change. Now let's start with melting. It is a change from solid to liquid by absorbing heat to break the force of attraction holding the particles together. The temperature at which a solid melts is melting point. So from the graph, we can see that A to B, the temperature of the solid increases to its melting point. B to C, the temperature remains constant because the heat is being absorbed to break the forces of attraction instead of just raising the temperature. At this stage, both solid and liquid are present. C to D, liquid heats as heat energy increases temperature. Freezing. It is a change of liquid to solid by cooling down liquid. The freezing point is the temperature at which liquid freezes. In the graph, we can see that A to B, liquid temperature decreases to freezing point. B to C, heat energy is released as particles slow down and settle in fixed and orderly position as in solids. The temperature remains constant because the energy released from the attractive forces made between the particles compensate for the loss of heat to the surroundings. Now, C to D, liquid cools to the temperature of the surrounding. Boiling is the change of liquid to gas by absorbing heat to break the forces holding them together. A boiling point is the temperature at which liquid boils. We can see that A to B, liquid temperature rises to the boiling point. B to C, Heat energy is absorbed by particles to break the attractive forces so that they move freely and far apart as gas particles. That's why the temperature remains constant at boiling point. C to D, gas heats as heat energy increases temperature. Okay, evaporation. It is the change of liquid to gas without boiling. It occurs below the boiling point on a liquid surface. It gives a cooling effect to the liquid body as molecules with greater energy escapes from the surface. Condensation is a change of gas to liquid. Heat energy is given out as gas particles slow down and move closer to each other to form liquid. Sublimation. It is the change of solid to gas without melting, and heat is absorbed during this process. Okay, for quick reviews, just check out this diagram. You can just pause the video and copy it on a notebook or take a screenshot for quicker access. Okay, next is Brownian motion was discovered in 1827 by the botanist Robert Brown. Brownian motion is the random motion of particles that are suspended in a medium like liquid or gas as a result of collisions with the surrounding gaseous molecules. An example is the diffusion of pollutants in air. But what is diffusion? Diffusion is the spreading and mixing of particles in gases and liquids. The particles move down their concentration gradient, that is, more concentrated to a lower concentrated area. To explain diffusion of gases, let's say bromine drops are placed in a jar. Another jar full of air is placed on top of that jar with bromine, separated with a cover. Cover is removed and bromine evaporates, filling both jars with dense reddish-brown vapor. Explanation? Bromine particles move from the lower jar into the space between air particles in the upper jar. At the same time, air particles move to mix with the bromine too. Eventually, all the different particles are mixed completely. Diffusion in liquids. When copper to sulfate crystals are placed in a beaker of water, the blue particles of the crystals are spread throughout the water by diffusion to form a uniformly blue solution. Okay. Now, the factors affecting the rate of diffusions are temperature and mass of particles. Temperature. The higher the temperature, the more particles absorb energy and move faster, so higher rate of diffusion. And the lower the temperature, the lower the rate of diffusion. Mass of particles. Greater the mass, the slower it diffuses. Okay. Now, a quick question. If hydrogen chloride and ammonia are gases which are given off by cotton walls soaked in their concentrated solutions and placed at either ends of a glass tube, when the gases react, they form ammonium chloride, which is a white solid. So, on which position on the diagram should that white solid appear? Think about it a little. Hint: hydrogen chloride is heavier than ammonia. I would suggest you pause the video and come up with an answer on your own before you get the answer from this video. Okay, so the answer is the compound would be produced closer to hydrogen chloride soaked cotton as its particles are heavier, so it diffuses slower. The reaction happens closer to the hydrogen chloride soaked cotton. Simple.